Title of the first section today is Dividing by Rational Expressions. In this section, we'll divide rational expressions, which again are fractions with variables. One definition or step for the section is multiply by the reciprocal. In this section, just like other sections, if we're dividing by a fraction, we'll end up multiplying by the reciprocal, which is the same fraction but flipped upside down. First question and first fraction, x minus 1 over x plus 4 divided by second fraction, x plus 3 over x plus 4. Again, when we have two fractions and we're dividing by a fraction, we can rewrite the first fraction as the same, x minus 1 over x plus 4. And looking back at the definition for the section, we'll multiply by the reciprocal. So instead of dividing, we can change that to multiplication. And the reciprocal, the second fraction, is the same fraction but flipped upside down. So x plus 4 will become the numerator, and x plus 3 will go to the bottom and become the denominator. From here, we can multiply like we did in previous sections, straight across. Each term in this case is a binomial, which has a letter and a number with a plus or minus sign. So instead of multiplying, we can rewrite the same expression in parentheses. So we'll have x minus 1 times x plus 4. And the denominator will have x plus 4 times x plus 3. Once we have a single fraction with all the factors in parentheses, to simplify or reduce, we can cross off the common factors. The common factor in this case would be x plus 4 and x plus 4. And x minus 1 and x plus 3 does not cancel, but we can leave that as our answer, x minus 1 in the numerator and x plus 3 in the denominator. The x's again do not cancel, since x minus 1 is different than x plus 3. Second question, and last question for the section. The first fraction we have is 3y plus 12 divided by 5y. And dividing this by a second fraction, y plus 4 over 10y. Again, the first step, we have a fraction divided by a fraction. We can rewrite the question. When rewriting, we want to factor when possible. We have 3y plus 12. If we factor that, we take a 3 out of each. Dividing by 3, we'll be left with y. And 12 dividing by 3, we'll have 4. So 3y plus 12 factors of 3, y plus 4. Divided by 5y stays the same, as it cannot be factored. Dividing again by a fraction, we can change to multiplication, and we'll end up flipping or taking the reciprocal of the second fraction. So 10y will become the numerator, and y plus 4 will be the denominator. Multiplying, we can multiply the fractions again straight across. Common numbers or coefficients like 3 and 10, we can multiply. 3 times 10 would be 30, and the y we can leave on there. So 3 times 10, y would be 30y. And the factor y plus 4, we can leave in parentheses in case this cancels out as a factor at the end. For the denominator, we have 5y times y plus 4, 5y would stay the same. And y plus 4 we can leave in parentheses. From here we have a single fraction that we can reduce to get our final answer. The numbers we can divide, 30 divided by 5 would be 6. The y's will cancel out. The y plus 4's, also the same factor, will cancel out. So the only numbers we have left, 30 divided by 5, which will be our answer of 6. Title of the last section today is More Complex Rational Expressions. In this section we'll continue to divide rational expressions. We'll have more complex or factoring techniques to simplify the answers. First question and first fraction, x squared plus 6x plus 8 over x squared plus x minus 2 divided by a second fraction, x plus 4 over 2x plus 4. Simplifying from here, again we can rewrite the second fraction using the multiplication of the reciprocal, and keep in mind we can factor each of the terms when possible. Looking at the first term, or first numerator, x squared plus 6x plus 8. If you remember from previous sections, we can factor this. This would factor using the diamond or x method. We'll take the last number 8, put that on top of the x, and the middle number 6 we'll put on the bottom of the x. And again, two numbers that we want to multiply to get 8, and those same two numbers add to get 6. Those numbers would be 4 and 2. 4 times 2 would be 8, and 4 plus 2 would be 6. So rewriting the numerator in factored form, the two numbers 4 and 2 will have x plus 4 and x plus 2. For the denominator of the same fraction, x squared plus x minus 2, again we can factor using the diamond or x method. The last number, negative 2, goes on top of the fraction, and the middle number, if there's no coefficient here, we can add a 1 or a positive 1. Two numbers that multiply to get negative 2, and those same two numbers add to get 1. Those numbers would be 2 and negative 1. 2 times negative 1 would be negative 2, and 2 plus a negative 1, which is the same as 2 minus 1, would be 1. So our two factors using 2 and negative 1, we'll have x plus 2 and x minus 1. The second fraction, again we're dividing by. So using the definition or property, we can multiply by reciprocal, which will be the same fraction flipped upside down. 2x plus 4 will be the numerator. Keep in mind though we want to factor when possible. 2x plus 4, we can take a 2 out. Dividing by 2, inside parentheses we'll have x, and 4 divided by 2 would be 2. So 2x plus 4 becomes a numerator. In factored form, it's 2 times x plus 2. And the numerator, which again will change to the denominator, stays as x plus 4 as it cannot be cancelled. From here, we can multiply the fractions straight across, or one other step you can do is called cross-canceling. cross-canceling instead of reducing or canceling from one fraction, you can reduce and cancel from opposite fractions as long as one term's in the numerator and one term's in the denominator. For example, x plus 4 in the numerator and x plus 4 in the denominator of fractions. We can cancel these before we multiply, since we have a x plus 4 and a x plus 4 on top and bottom of the fraction. Looking for other factors that we can cross-cancel. If we use a x plus 2 in the denominator of the first fraction and a x plus 2 in the numerator of the second fraction, x plus 2 and x plus 2, we can divide those or cancel those out. Looking at the remaining terms, x plus 2, 2, and x minus 1, these do not cancel. So we can write these as our answer. The 2 coefficient can go in front. X plus 2 we can write after. Divided by x minus 1, which is on the bottom of the fraction or denominator. So our final answer, after reducing or cross-canceling, we'll have 2 times x plus 2 divided by x minus 1. Second question, and last question for the section. The first fraction we have is x squared plus 10x minus 11 divided by x squared plus 12x plus 11. And dividing by a second fraction, or second term, which will be x minus 1. For this problem, we have a fraction divided by a single term. If we wanted to, we can make this second term a fraction by putting a 1 on the bottom. And from here, we can solve like the previous question by factoring first and then multiplying by a reciprocal. Looking at the first term or numerator, x squared plus 10x minus 11. Again, we can factor this by using the diamond or x method. The negative 11 we'll put on top, and 10 will go on the bottom. Two numbers that multiply to get negative 11 and add to get positive 10. Those numbers will be 11 and negative 1. 11 times negative 1 is negative 11, and 11 plus negative 1, or 11 minus 1, would be 10. So the first factor would be x plus 11 and x minus 1. Factoring the denominator. Again, x squared plus 12x plus 11, the trinomial we can factor with a diamond or x method. Numbers that multiply to get 11 and add to get 12. Those numbers would be 11 and 1. 11 times 1 would be 11, and 11 plus 1 would be 12. So the factors would be x plus 11 and x plus 1. Again, we're dividing by a fraction, so we can change that to multiplication. The reciprocal, flipping the second fraction upside down. This time we cannot factor, but the 1 will go to the numerator, and the x minus 1 will go to the denominator. From here again, you could multiply straight across, or again cross-canceling or reducing. We have a x minus 1 in the top of the first fraction and a x minus 1 in the bottom of the second fraction. So before we multiply, if you want to, you can cross-cancel or divide those out. Looking for another term that we can cross-cancel. The first fraction, we have x plus 11 over x plus 11. If it's the same fraction again, we can cross them off, as long as one's factor is numerator and one factor is in the denominator. The last terms, 1 and x plus 1, do not cancel. But rewriting our answer, the 1 is the only number left in the numerator, and x plus 1 is the only factor in the denominator. So our final answer is 1 over x plus 1.